Good afternoon and welcome to this session number 8 from the chapter of Semiconductor Devices and Circuits. The topic is the P-Type Semiconductor, and based on this topic I have written here two important points in order to understand this type of semiconductor in brief. So P-Type Semiconductor is formed when a trivalent doping element such as indium, boron or aluminium are doped in intrinsic semiconductors. Now intrinsic semiconductors are those conductors which does not has any impurity, and the trivalent doping element is an impurity which is doped in the intrinsic semiconductors in order to increase its conductivity. So a P-type semiconductor is formed when a trivalent doping element which can be an indium, boron or aluminium are doped in the intrinsic semiconductors, and the commonly used this intrinsic semiconductors are silica and or germanium. So in this case, the trivalent doping element I have taken it as aluminium. So the trivalent element means that the number of valence electron in the aluminium will be 3. The number of valence electron in the silica, and the silica is a intrinsic semiconductor. So there are 4 valence electrons in the silica atom. So what happens is that the 3 valence electrons of this dopant atom, they form a covalent bond with the 3 valence electrons of each of the 3 silica or the germanium atoms which are surrounding this dopant atom. And as a result, what happens that now since the dopant atom has got only 3 valence electrons, so what happens is that the dopant atom now does not has any electron to share with the 4th silica or the germanium atom. So since the dopant atom does not has any electron to share with the 4th silica or the germanium atom, the bond which is formed between this 4th silica atom and this dopant atom creates a hole in the lattice. Now in the case of this P-type semiconductor, the majority carrier are the holes and the minority carriers are the free electrons, and as we increase the concentration of the dopant, the concentration of the minority carriers, that is the free electrons, reduces. So in the case of the P-type semiconductor, the number of holes is greater than the number of free electrons, and there is one more important relation between the concentration of the hole and the concentration of the free electron, which is given by NH into Ne. That is the concentration of the number of holes and the concentration of the number of free electrons in thermal equilibrium is also given by this formula, that is NH into Ne is equal to Ni whole square, where Ni is the intrinsic carrier concentration. So this is an important formula, and based on this formula we will be solving few numerical problems in the coming few sessions. So in the next session now I will be coming up with a question in which we will try to find the number of free electrons and the number of holes in an intrinsic semiconductor which has been doped with a certain impurity. So till then, have a nice day. Bye.